Hey there, physicists. Let's go through one more level 10 challenge question from the energy bar charts pair deck. So this was the second question that we had. So it's just a different little piece of the roller coaster. It says, assume the height of hill A in the figure is 40 meters relative to the bottom of hill B, and the roller coaster starts from rest at the top. So part B, the question says, use the energy bar charts from the previous slide and the conservation of energy concept to determine the height of C, where it will have half of the car's maximum speed at B. Okay, so there's kind of a lot to unpack there. So let's go ahead and take a look at what is going on. So the big piece of information, the key that we're looking for, is that we want the height here. I'm going to call this H sub C. That's a little bit hard to see. Let me see if I can write that again and it'll show up. There we go. H sub C, where the velocity, so we're going to find H sub C, where V sub C is equal to 1/2 V at B. Okay? Hopefully that makes a little bit more sense. So at A, it's not moving. At B, it's moving really fast. And then at C, it's still going, but it's not going nearly as fast. I want to know how high up it goes. Okay? So you can look at the energy bar charts to kind of get your head around that. But then to actually do the application of conservation of energy, we really just need to write down that statement. So really what we're saying is that the energy total at any two places has to be equal. Okay, so really what we're looking at here is to say that the energy at A equals the energy at B, which equals the energy total at C. We've only got gravitational potential and kinetic involved in the story, so let's go ahead and write down what we have where. So we've got gravitational potential energy at A and no kinetic energy at A. I'm going to write it down in there just so we've got it, but then I'm going to go ahead and just say, hey, by the way, it's 0. That has to equal the gravitational potential energy at B plus the kinetic energy at B. But then again, right? Oh my gosh, that's where it's 0. So the gravitational potential energy is going to be 0 there. And then finally, at C, we've got gravitational potential energy plus kinetic energy. And those, neither one of them is 0. Okay, so let's think about kind of how to get an expression for half of the velocity. So we can say that, well, you know what, let's focus just on this piece of the equation to start with. So if we do that, the kinetic energy at B is just going to be 1/2 the mass times the velocity at B squared. And the expression on the right-hand side is going to be mg h at C. That's really what we're looking for, right? It says determine the height. So h at C, that's our kind of unknown, plus 1/2 mv at C squared. Okay. Now we can get an expression for VC in terms of VB, and then we should be able to solve for the height. So instead of writing VC here, this is what I'm going to do. I'm going to be a little bit tricky. This is the clever manipulative part of how to solve problems like this. Instead of writing VC, I'm going to say that VC equals 1/2 of VB. And then I'm going to plug it back into that same statement that I had just a second ago. So this is what we're going to do. Oh, by the way, just to save on graphite ink my time, I'm going to notice that there is a mass in each one of those expressions. I'm just going to get rid of it. It does not matter how big that car is. That's one of the crazy things in conservation of energy, is that when you're dealing with just gravitational potential and kinetic, the mass of the object doesn't matter. All right, so let's take a look at what we've got here, what our expression now looks like. So I'm going to scooch it over just a little bit, just so I've got some space. 1/2 VB squared equals G times HC plus 1/2 VB squared. Okay, so hopefully that makes sense. All I'm doing here is subbing this in for that V sub C. Now I have to square both the 1/2 and the VB. So this is going to look like 1/2 times 1/4 VB squared. Okay, and I can combine that 1/2 and 1/4 to give me 1/8 VB squared. I'm going to go ahead and write down the rest of my expression here, equals 1/2 VB squared. This is a little mathy, but you know what? It's kind of fun to do this now and then. Again, remember, this is a level 10 setup, level 10 situation This part right here is what I want to make sure everybody knows how to do. This kind of digging in part, it's just kind of fun and interesting. I'm going to put all the VB squareds on one side, and then we can figure out kind of what to do with this information, okay? So we can say, let's see, we're going to say 1/2, oops, let me get that back into a regular color, 1/2 VB squared minus 1/8 VB squared equals G times H sub C. And I can combine these now. I've got 1/2 and I'm going to subtract 1/8. So remember 1/2, that's going to be 4/8 minus 1/8. So that's 3/8 VB squared is equal to GH sub C. You might be like, thanks, Miss K. I don't know what to do with that, but never fear. I've got a little bit more physics that I get to use here. I'm going to use this statement of conservation of energy. Here we go. Are you ready? Buckle up, you guys. This is good stuff. All right, so here we can say that gravitational potential energy at A plus kinetic energy at A is equal to gravitational potential energy at B plus kinetic energy at B. Hey, wait, that goes to 0 and that goes to 0. MGHA is equal to 1/2 MVB squared. Why in the world are you doing this, Miss K? I'll tell you why I'm doing it. Because I don't have any idea what VB is. But I do know what H sub A is. And now I can have an expression for VB in terms of HA. My masses are going to go away again. I know that VB is equal to the square root of 2GHA. You with me there? Hey, wait, let's make our life even better. VB squared, wahoo, is equal to 2GHA. Okay? Substituting like it's nothing. Here we go, friends. I'm so excited. I hope you're excited too. I'm going to take this thing and we'll plug it in right here. So now, hold on to your hats. I've got 3/8 times 2GHA is equal to GHC. What? Okay, hold on. Those G's go away, don't they? And that means I've got 3 times 2, which is 6/8 of HA is equal to HC. And I know what HA is, right? I know that HA is, well, I don't remember, but I can look. It was 40 meters. So what is 6/8 of 40? Whoops. 6/8 or 3/4 of 40. Oh, I could have done that in my head, couldn't I? Ha! I'm a rock star. It's 30 meters. That's how high up it needs to be. One note here, and I should have mentioned this at the beginning. This is not halfway up, is it? No, it isn't. No, it isn't. It's going to be 2/3 of the way up. Or excuse me, 3/4 of the way up. Okay. Thanks for playing. Have a great day.